We're doing a deep dive on a tool called NCS, the Network Configuration Scrubber.
And it's more than just a piece of software. It's a really fascinating answer to a modern problem.
Totally. The whole premise is, well, it's simple but also kind of radical today. How do you analyze your most sensitive infrastructure data without it ever leaving your computer?
It's this local first idea.
Yeah.
It just flips the whole script on everything in the cloud.
It really does. But before we get into the tech, which is actually very clever, let's stick with that problem. I mean, to an outsider, a config file is just, it's gibberish. Why is it so radioactive? What's the big deal?
Okay, so imagine a burglar. They're trying to rob a bank.
Okay.
Usually they have to guess, right? Guess where the vault is, guess the camera locations, the codes. A configuration file is.
Yeah.
It's like the bank giving the burglar the blueprints.
It tells you everything.
Everything. You've got internal IP addresses, so an attacker knows exactly how your network is laid out, where the jewels are, where the weak spots might be. It has your entire topology.
And things like SNMP strings.
Oh, yeah, which are basically management passwords. And if they're old, they might be incredibly easy to crack. Sometimes you even find hashed passwords, or heaven forbid if someone was really sloppy a decade ago. Clear text credentials.
So if you upload that to some public AI model to, help debug it,
You basically just pasted your bank blueprints onto a giant billboard in Times Square.
you've created a massive compliance nightmare.
A huge one.
So this creates a deadlock. And the source material for our dive today calls this a catch-22. You have option A, the manual review. You, the tired engineer, just reading line by line by line.
Which is so slow, it's tedious, and let's be honest, humans are just not good at it. We get tired, we miss things. You might miss one single line allowing, say, telnet access from the public internet just because you blinked.
Or there's option B, the shadow IT route. You get a little desperate. You want to go home, so you try to scrub a few lines yourself, pray you got all the important stuff.
And you upload it anyway. And that's where the risk lives, that hesitation. The source material says engineers are hesitant to upload configurations.
Well, yeah.
But think about what that really means. If I'm hesitant to share a file, I can't easily ask you for help.
Right. Collaboration just dies on the vine.
I can't send it to a vendor for support without a huge process. I can't give it to a junior engineer to learn from because I can't trust them with the admin keys.
Yeah.
So what happens? I work in a silo. I try to fix it myself, which takes longer and is, frankly, probably riskier.
And silos are where mistakes get made and never caught. Okay, so enter Todd Wilson.
The creator of NCS.
I always find it so interesting to see who builds these kinds of tools. This isn't some new grad with a theory. This guy has, over 15 years in the trenches? Network, cloud, cybersecurity.
You can tell. This is a tool that was clearly born out of pure frustration. He lived that deadlock we just talked about. He saw that pattern of, I need speed, but policy demands security over and over again.
And he wanted to break that trade-off.
Exactly. So he built NCS.
So let's get under the hood, because the architecture is really the whole point here. It runs in the browser. Now, normally when I hear runs in the browser, I immediately assume it's a SaaS tool. I assume my data is going to a server somewhere.
And that's the clever trick here. It looks and feels like a website, but it doesn't phone home like one. It's a local-only architecture.
Okay, explain that. How is it in my browser but not, on the internet?
So think of your browser not just as a window to the web, but as an engine that can run code. When you load the NCS page, you're downloading the application's logic character, all the JavaScript, directly into your computer's memory.
So the processing engine is running inside my computer's RAM, not on some server somewhere.
Precisely. It's like a self-contained app. And the source material is super clear about what it calls the never list. This is its security guarantee. Configs are never uploaded. They are never stored. And this, for me, is the big one.
What's that?
No telemetry.
That is rare.
Almost unheard of. Even so-called secure tools usually want to send back little pings. User clicked this button, user processed a Cisco file. But if you're working on, say, a classified government network, even that kind of usage stat could be considered a data leak. NCS strips all that away. It's a ghost.
Which means you can actually use it on your real production data. You don't have to make up some dummy file to test it.
That's the unlock. The tool is the sanitizer. You don't have to sanitize the file before you use the tool.
Okay, so we've established it's safe. We're in the cone of silence. What does it actually do? The outline breaks it down into 3 layers. Let's take layer 1. Configuration sanitization.
The digital black marker.
I like that. So I feed in my raw config file. All the secrets are in there. What happens?
It just scours the text for anything sensitive. The obvious stuff, first IP addresses, subnets, it masks all of those. So the map of your internal network basically vanishes.
Okay, topology gone. What's next?
The keys, credentials, any kind of authentication string, hash passwords, those SNMP strings we mentioned, it just rips them right out. It's looking for anything that could be used to get access.
The outline also mentions it scrubs interface descriptions. I wanted to pause on that because that sounds kind of trivial. It's just a label on a port, isn't it? Why is that sensitive?
Oh, interface descriptions are one of my favorite things to find in an audit. They're the most hilarious and the most dangerous part of a network.
How so?
Because engineers are human. We leave notes for ourselves. You'll see descriptions like uplink to CEO's home office or backdoor for vendor X, DO not touch.
Wow, okay, yeah, I can see how that's a problem.
Or my favorite, temp fix for server that only allows unencrypted traffic. If an attacker sees that, they don't have to scan your network. You've literally given them a guided tour of all your vulnerabilities.
It's like social engineering gold just sitting there in the code.
Exactly. So NCS sanitizes all of that too. It creates a clean version of the file where the technical logic is still there, but all that dangerous context is gone.
And the real value there is that you can then share it.
Yes, that's the operational unlock. The file is harmless now. You can email it to Cisco support and say, why is my router crashing? And you don't need 3 levels of management approval to do it.
You could post a snippet on Reddit to ask for help.
You can collaborate again. It breaks that bottleneck.
But it's not just a sensor. It doesn't just black stuff out. It actually reads the file.
Yeah.
Which brings us to feature number 2, automated risk analysis.
Right. This is the second set of eyes part. After it cleans the file, it analyzes it. It looks for all the things a tired human is going to miss.
So what are the usual suspects?
The classics. Insecure protocols. Finding Telnet enabled where it should be, SSH.
The zombie protocols that just won't die.
Right. Stuff that was fine in 1999, but is just a disaster today. It looks for HTTP on management interfaces instead of HTTPS, weak authentication methods, that kind of thing.
It's basically doing a code review on your infrastructure config.
Yeah, and it's checking against established best practices. It's also looking for things that just cause instability. Not just security, but why does the network slow down at 3 p.m. every day?
Yeah.
Maybe there's a weird routing loop. NCS flags those deviations.
And again, the source material is very specific here. The goal isn't to replace the engineer.
No, not at all. It's to accelerate review.
I like that phrase. It clears the haystack for you so you can just find the needle.
That's it. Instead of 4 hours finding the problem and 10 minutes fixing it, it's 1 minute finding it and 10 minutes fixing it. It just completely changes the economics of your time.
Okay, so finding the problem is one thing, but explaining that problem to your non-technical boss who holds the purse strings, that's a whole other challenge.
The eternal struggle. Engineering versus management.
And that's the third feature, reporting. How does NCS bridge that gap?
It's smart. It generates 2 different kinds of reports. First, there's the technical one. That's for us. It says, line 402, this is broken, fix it. It's an actionable to-do list.
But the CISO doesn't care about line 402.
Not one bit. The CISO or the IT director, they get the executive summary. NCS translates the technical details into business risk.
So give me an example of that translation.
Instead of saying, we have Telnet enabled on VLAN 10, the report says something like, we have a critical vulnerability in our administrative access methods that could lead to an immediate system breach.
It speaks the language of risk and money.
And that's how you get budget to fix things. You go to your boss and mumble about protocols, their eyes glaze over. You show them a report with a big red circle that says 15 critical risks identified, and suddenly they're listening.
So we have a tool that scrubs, analyzes, and then reports, all on your local machine. Who's actually using this? The source listed a few use cases that were pretty interesting.
Well, you've got the obvious ones. Security assessments, pre-deployment validation, checking the config before you push it to a live device.
They measure twice, cut once.
Exactly. But the 2 that stood out to me were MSPs, managed service providers, and education.
Right, the MSPs who manage networks for other companies.
Yeah. Imagine you're an MSP taking on a brand new client. You have no idea what kind of mess is waiting for you in their server rack. You can run their configs through NCS as a sort of health check.
Like a doctor taking a blood test before they do anything else.
That's a great analogy.
Yeah.
You get a baseline of the situation without having to take custody of their sensitive data and upload it to your own systems. It builds trust.
And the other one was education for networking students.
Which makes total sense when you think about it.
Yeah.
It's a huge problem for professors. They want to show students what real-world networks look like. Not the perfect, clean textbook examples, but the messy reality.
But they can't just show them the campus firewall config.
Of course not. That's a massive security risk. But with NCS, a professor can take that real messy file, scrub it clean, and then hand it to the class and say, okay, here's a real-world problem. Find the errors.
That's a game changer for learning.
It lets them work on the real thing without the risk. It bridges that gap between theory and practice.
Okay, I want to clarify one thing, though. Where does a tool like this sit in the grand scheme of things? You've got your big SIEM platforms, your network management dashboards. Is NCS trying to replace those?
No, absolutely not. The source is very explicit about this. It complements them.
So what's the dividing line?
A SIEM is looking at logs. It's watching live traffic. It's asking what is happening right now, who's logging in, why is traffic spiking from this IP.
It's the security camera watching the building.
Perfect. NCS is checking the building code. It's not watching the traffic. It's checking the road signs and the locks on the doors. It focuses on configuration level risk.
So the SIEM tells you someone is actively breaking in. NCS tells you that you left the back door unlocked in the first place.
That's the perfect way to put it. It's preventative hygiene. And the source material notes this is an area that's often overlooked. We get so obsessed with watching the live traffic that we forget to check the fundamental settings that control it.
So let's bring this all back to that engineer we started with. Cold coffee, glazed over eyes.
Right. NCS basically gives them their time and their sanity back. It solves that deadlock. You can analyze the real data, find the risk fast, and share the results safely.
And maybe get to go home on time.
That's the dream. Or at least move on to a more interesting problem instead of hunting for a typo for 4 hours.
It really feels like a shift in the philosophy of our tools. I mean, for the last decade, the big push has been cloud everything.
Oh yeah, upload it, let the AI process it, put it in the cloud.
And NCS is pulling hard in the opposite direction. It's saying, no, keep it local, keep it private, keep it safe.
It's a return to basic hygiene. It's a recognition that some data is just too sensitive to ever leave your control.
What's interesting is it makes the safe way the easy way. Usually security adds friction. You have to jump through hoops. This actually removes friction while adding security. That's really rare.
It is. It acknowledges how engineers actually work. If you make security too hard, people will find a way around it. Make it easy, and they'll actually use it.
So here's the thought I want to leave our listeners with. It's a bit of a provocation based on this whole local first idea. We are in the absolute golden age of AI right now.
The gold rush.
Everyone is scrambling to push their data into these massive cloud models. We want AI to write our emails, write our code, analyze our business. But NCS proves that for the most critical, most sensitive data, the actual blueprints to your kingdom, the best solution might be to run in the complete opposite direction.
To go offline. Disconnection is a feature.
Exactly. As cyber threats get more sophisticated, as data privacy laws get even stricter, are we about to see a renaissance of these local-first tools? Will the new gold standard for professional software be the one that promises to never, ever talk to the internet?
It's a really powerful question. Maybe the ultimate luxury in a few years won't be cloud connectivity. Maybe it'll be the ability to work in your own digital Faraday cage.
Something to think about the next time you're hovering your mouse over that upload button. Thanks for listening to this deep dive into the network configuration scrubber. Stay curious, stay secure, and we'll see you on the next one.
Analyze with NCS.